Imagine stepping onto a world where the sun doesn't just rise and set. It hesitates, hangs motionless for days, then creeps backward like it's having second thoughts, before finally climbing again. A place so close to the sun that daylight bakes the ground hot enough to melt metal. Yet night plunges into Arctic cold faster than you can blink, where the very crust is still wrinkling and splitting as the planet literally shrinks beneath your feet. And hidden pockets of ice survive in eternal darkness right next to the furnace of our star. This isn't some dystopian sci-fi planet. This is Mercury, our solar system's smallest, densest, and arguably most bizarre rocky world. For generations, astronomers wrote it off as a lifeless, scorched cinder, barely worth a second glance. But probe after probe has proven us spectacularly wrong. Mercury isn't dead. It's restless, contradictory, and in many ways terrifying in its alien indifference to what we think a planet should be. Today, we're diving deep into why Mercury keeps rewriting the rulebook on how planets form, live, and die. Stick around, because by the end, you'll never look at our innermost neighbor the same way again. Let's start with the basics that would instantly kill any human visitor. Heat and cold on steroids. Daytime highs hit about 430 degrees Celsius, hot enough to turn lead into a puddle and make zinc glow like embers. But flip to night, and it crashes to minus 180 degrees Celsius. That's a 600 degrees Celsius swing, dwarfing anything else in the solar system. Earth's worst deserts might see 40 to 50 degrees Celsius differences. Mercury laughs at that. Why the insanity? No real atmosphere. Its exosphere is just stray atoms so sparse they rarely bump into each other. Heat doesn't linger. It blasts into space the moment the sun dips below the horizon. Add Mercury's bizarre rotation. Not tidally locked as we thought for over 100 years, but in a 3-to-2 spin orbit resonance. It spins 3 times for every 2 laps around the sun. Result: a day from sunrise to sunrise lasts 176 Earth days, longer than 2 of its own years, 88 Earth days each. And because its orbit is eccentric, near closest approach, perihelion, orbital speed briefly overtakes rotation. Stand in the right equatorial spot, and you'd watch the sun rise, stall, reverse course like it's rewinding, then resume upward. A double sunrise. In my view, that's one of the most psychologically unsettling things in astronomy time, and light behaving in ways our brains aren't wired for. Personally, I find this resonance fascinating because it shows how gravitational tugs from the sun can lock worlds into rhythms that feel almost choreographed. Compare it to our moon's tidy 1-to-1 lock, or Venus's ultra-slow backward spin. Mercury's dance is chaotic elegance, a reminder that orbital mechanics can produce surreal beauty alongside brutality. Now let's go deeper. Literally, cut Mercury open, and you'd see an iron core swallowing approximately 85% of its radius and approximately 70% of its mass. Earth's core is only approximately 15% by volume. Mercury is basically a giant metal ball wearing a thin 400-kilometer rocky skin like a cannonball dipped in concrete. How did this happen? The old textbook answer: a colossal collision early on vaporized and ejected most of the mantle, leaving the dense core behind. Dramatic, right? It even explains the huge Caloris Basin, a scar bigger than Texas from that ancient violence. But NASA's Messenger mission, 2011 to 2015, blew holes in that story. It found volatiles everywhere: sulfur, potassium, chlorine elements that boil away at high temperatures. A giant impact should have cooked them off, yet here they are, abundant on the surface. This puzzle forced scientists to rethink everything. Maybe Mercury formed farther out in a cooler zone, grabbed volatiles, then spiraled inward. Or perhaps comets peppered it later with fresh material. A 2022 simulation. I love suggests a hit-and-run grazing collision gentler, strips mantle without total volatile loss. It fits the data eerily well. To make this relatable, think of Mercury like a poorly baked cake. The outside got scorched and cracked, but somehow the filling stayed gooey and rich when it should have evaporated. That's the volatile paradox evidence of a more nuanced birth story than simple smash and grab. And the drama isn't ancient history. Mercury is actively shrinking as its core cools and contracts. The crust buckles into massive thrust faults called lobate scarps, some over 1,000 kilometers long, taller than skyscrapers. Total shrinkage, roughly 7 kilometers in diameter over billions of years. Imagine an apple drying out. The skin wrinkles into ridges. But on Mercury, those wrinkles are cliffs where rock has shoved over rock. For decades, we assumed this stopped eons ago. Then Messenger's low altitude passes in 2013 to 2015 spotted tiny, pristine scarps and Graben's fresh cracks, suggesting shrinkage continues today. Geologically, some may be under 300 million years old yesterday in cosmic terms. This implies ongoing Mercury quakes, low-energy tremors rippling through a world we called dead. Real-life parallel. Think of Greenland's shrinking ice sheet or Earth's tectonic plates still grinding. But Mercury does it alone. No plate tectonics, just global contraction like a cooling engine block stressing its casing. If we could place seismometers there, we'd hear a planet groaning as it contracts. Then there are the hollows, thousands of bright, shallow pits, often inside craters, glowing like fresh wounds. No rims, flat floors, young, some possibly less than 50 million years. Messenger showed they're forming now via sublimation. Solar wind and heat vaporize trapped volatiles, sulfides, graphite. Rock collapses inward. It's surface evaporation, a geological process unique to Mercury. Example, picture dry ice on Earth, sublimating in sunlight, leaving pits. Scale that to planetary level, but with rock instead of ice and no protective air. Hollows prove Mercury still has hidden volatile reserves, contradicting the stripped, bare narrative. To me, it's poetic. Even the closest world to the sun clings to its secrets, slowly exhaling them into space. Don't forget the magnetic field. Only Earth and Mercury among rocky planets have active dynamo-generated global fields. Mercury's is weak, approximately 1% Earth strength, but real, powered by a liquid outer core layer, despite the planet's small size. Small worlds cool fast, cores solidify. Yet it's wildly asymmetric offset north by approximately 20% of radius. The south gets hammered harder by solar wind, eroding surface differently. Analogy, it's like a lopsided shield protecting the north better, leaving the south more scarred. Over time, this could explain hemispheric differences we see in composition. It's another reminder. Mercury refuses to fit neat. We've barely begun. Only 2 missions visited. Mariner 10, 1970s flybys, half-surface map, and Messenger, full map, but many questions. We've sent dozens to Mars. Mercury got crumbs. That's changing with Bepi Colombo, ESA/JAXA. After years of flybys, including stunning 2024 close passes and first mid-infrared views. It enters orbit late 2026. Dual orbiters will map composition, monitor hollows for new growth, probe magnetic asymmetry, and scan polar ice in permanent shadow water ice on the hottest planet. Mind-blowing. Mercury is contradiction incarnate. Hottest/coldest, smallest/densest rocky world. Day longer than year, shrinking yet active, ice in sunlight's glare. We dismissed it as boring. We were wrong. Takeaway. Mercury teaches humility. Every time we think we understand planetary formation or geological death, a world like this upends it. It reminds us the solar system is full of surprises, that even the simple places hide complexity, and that exploration pushing probes to hard-to-reach worlds is how we grow wiser. So next time someone calls Mercury boring, smile. Tell them it's the solar system's quiet rebel, still shrinking, still exhaling secrets, still forcing us to rethink everything. Thanks for joining me on this journey into the abyss closest to our sun. If Mercury's story blew your mind, like, subscribe, and drop in the comments. What's the weirdest planetary fact you've heard? See you next time. Stay curious.